Consider a location out in space. We will denote that as a single point. If you were to create a boundary around this single point, how large do you want the boundary to be? Do you want a 10-foot boundary? That means that from this location, you do not want anything to come within 10 feet of you. But that's not just in the western direction, right? That's also east. Ten feet south of you. And of course, 10 feet north of you. And again, it just doesn't stop there for all four of those directions, right? We also have northeast, we have southeast, southwest, and northwest. But in general, from that fixed point in the middle, anywhere around you, if it's within 10 feet, you want space. You want a boundary that is 10 feet from a fixed point. So what happens here is we end up creating a perimeter around a fixed point in the middle, and that perimeter actually makes up graphically a geometric circle. So I'm going to zoom myself in just a little bit here. It says here that a circle is the set of all points that are in the plane, the XY plane. So a circle is a set of points that are a fixed distance from a point in the middle called the center. The fixed distance is called the radius of the circle. So for example here, I chose my location here and I decided to fix my distance. How far do I want to be away in each location? I wanted a 10-foot distance, or I wanted a 10-foot parameter from my location. That 10 feet of distance was for each direction around me. Imagine standing in the middle and looking everywhere around you. You would be looking at a circle overhead. You would just create that of a circle. For that circle, you are the fixed point in the middle. Now, what are your boundaries around you? The boundary in this case here is the radius. As you see according to the photo, go back to the full view there, from my fixed point in the middle, I have free range to room, or sorry, free room to range, free roam to range. That's what I'm not sure. Okay, from the fixed point in the middle, 10 feet to the left, 10 feet north, 10 feet south, 10 feet to the right. That is my radius. My radius is my fixed point, my fixed distance rather, from the point in the middle, our center, to any point located on the outside of the circle. So again, the circle is the collection of our outside points. All of these points out here, they make up the circle. It said a circle is a set of points. So that's our circle. Our circle is going to have a center with a fixed distance to it, and that distance is the radius. The radius is the measure from any point, any of the infinite points, right? There are an infinite number of points or ordered pairs that make up the graph of this circle. Any one of those points, its distance, notice I'm using the word distance, we have a distance formula. Any point on the outside here, and the circle in the center, or the point in the center, has a fixed distance of 10 in this case here. Let's recall the formula for distance. The distance formula said, according to Pythagorean theorem, a squared plus b squared equals c squared. You can solve for c by taking the square root. We are taking the distance between our x coordinates and squaring, adding it to the difference or the distance between our y coordinates squared. So here, what are the two coordinates we're looking at? In this formula, it's the x1, y1 point, and it's the x2, y2 point. Well, here it's our center and any point that's on the circle. So let's go to our formulas here. Using the distance formula, we're going to let d, what is our distance? That's being defined by the radius. Make sure that I am on the slides. And our center, we are going to use the coordinates h, comma, k, where h denotes the x coordinate for the center and k denotes the y coordinate. So there, instead of x1 minus x2, we are going to say x minus h, where again, h is the x coordinate of the center, x is the x coordinate for any of the infinite points that lie on the graph of the circle. For the y coordinates, we will write y minus k, where the k represents the y coordinate for the center of our circle, and the y variable represents the y coordinate for any of the infinite ordered pairs that make up the graph of our circle. So this comes directly from our distance formula. Now, squaring each side of the equation, we have that r squared is equal to the square of x minus h plus the square of y minus k. So that x minus h quantity squared plus y minus k quantity squared is equal to r squared, where we want to be reminded that r represents the radius of our circle, that is the distance between the center and the outside of the circle. The ordered pair h comma k, so what are we subtracting from x? Whatever we subtract from x, that is the x coordinate for the center of our circle. What are we subtracting from the variable y? Whatever we subtract from the variable y inside the parentheses squared, that is the y coordinate for our circle. R squared, by taking the square root of what our equation is equal to, we can find our radius r. Let's look at some examples here. It says identify the center and radius of the circle with the equation of x minus 4 squared plus y squared equals 49. Now, as we said here, our variable x is in a parenthesis squared, so it's in the standard form as we see above. What are we subtracting away from the x? We are subtracting 4, so the x coordinate of our center, denoted with the capital C, I'll erase here, and I'll write out x minus 4 squared plus y squared equals 49. Going to the full view, we want to identify the center. We see that this is in fact the equation of a circle. And how do we know? Notice that this variable x, even though we're subtracting 4, we are eventually squaring the value. This binomial squared will give us a trinomial. The trinomial, of course, we can multiply that out. X squared minus 8x plus 16. That trinomial plus y squared is 49. So that equation involving two variables has an x squared and has a y squared. Because we have an x squared and a y squared, this no longer makes this a parabola, it makes it a circle. Any formula with an x squared and a y squared, you want to think circle or some form of circle, maybe an ellipse. Think about a circle that's elongated, could be an ellipse, could be some other form as well, but the x squared and y squared indicate a circle. If it was just x squared and y, we would have some form of quadratic, and that would be a quadratic up or quadratic down. If it was x and then y squared, we would still have a quadratic, but no longer flipped up, it would be flipped on its side. Because recall that we look at functions or equations as y equals some number x or some number x squared. So we write our equations where y depends on the x. So our functions and our graphs move up and down, somewhat side to side. Of course, you have to think about parabolas. Y equals x squared, x equals y squared, we'll flip that on its side and move from left to right. But I digress, we're here. We're subtracting 4 from x. So the center of this circle will have x coordinate 4. Well, what are we subtracting from the y here? It just says y squared. There is no, the y is not in parentheses and we're not subtracting some number. That, if we think about that here, y squared can be viewed as y minus 0 squared, because we know that at any rate y minus 0 is simply y, and thus we're squaring y. We think of it or we view it in this sense to understand why, in fact, our y coordinate is 0. It's because we're not subtracting anything from our variable y. Over here, we subtract 4 from the x, and that's being squared. Thus, the center is 4. There is no subtraction over here when we square. So the y coordinate is 0. Now, x minus h squared plus y minus k squared equals r squared. So here, r squared equals 49. Therefore, using the square root method, the square root of 49 is plus or minus 7. But for a radius of negative 7, that means we have a distance of negative 7. And as we know, distance is not negative. Thus, the radius is 7. So to identify the center and the radius for the following equation, noting that this is a circle, because the variable x is being squared, the y is being squared, the center with x coordinate 4, notice it's the opposite of what that sign is, because we're subtracting 4, thus 4 is the x coordinate. The y coordinate is 0. The radius here, taking the square root, is 7. To find the center and radius for the following equation, x minus 3 quantity squared plus y plus 2 quantity squared equal to 36. Consider again, what are you subtracting from the x coordinate? What are you subtracting from the y coordinate? For the x coordinate, to determine the center, we are subtracting 3. Therefore, our x coordinate is positive 3. For the y coordinate, what are we subtracting from y? Notice here that we are not subtracting. We are actually adding 2. But that does not mean that 2 is our y coordinate, because again, we're asking what are we subtracting? Y plus 2 is the same as y minus negative 2. Therefore, the y coordinate is negative 2. A way to remember this is, notice that it says minus 3 and it says plus 2. Just write the opposite of what those look like. The minus 3 becomes positive 3. The positive 2 becomes minus 2. What are you subtracting from the variable? Remember that radius and this whole idea of the circle equation is defined using the distance formula. Distance means difference. What is the distance between 3 and 8? The distance is 5. We can determine that because 8 minus 3 is 5. So distance deals with difference. What is being subtracted? Center in this case, positive 3 comma negative 2. The radius here is equal to 6. Because again, the formula there says that the circle equation equals r squared. So what is the constant? Move it to the right. Taking the square root of the constant, we get 6. So we'll open up the screen a little bit here. For the center and radius of the equation, squaring x minus 3 plus squaring y plus 2 equal to 36. Center 3 comma negative 2 with radius equal to 6. For problem 68 and 71, if you would like to go ahead and pause the video now, and you can work through these two examples. Identify the center and radius of each circle written. For number 68, we have here that x minus 5 is being squared, plus y squared equals 16/25. So for number 68, we do have it in the standard form. The x is being squared eventually, the y is being squared, so we do know it's a circle. So the center here, for our x coordinate, we are subtracting 5 from x, so our x coordinate is 5. For the y coordinate, we have y squared, which tells us that the y coordinate for our center is 0. If our equation for the circle in standard form equals r squared is 16/25. So to find r, we solve for this mini equation here, r squared equals 16/25, taking the square root of each side. Well, what is the square root of our fraction? Nice enough here, when you take the square root of a fraction, it's similar, or not similar, it's equal to, according to our properties of radical expressions, the square root of a fraction is equivalent to the square root of the numerator divided by the square root of our denominator. Square root of 16 divided by the square root of 25. Each of these are easily obtainable because both of these numbers are perfect squares. Square root of 16 is 4, square root of 25 is 5. For a radius of 4/5. So we have a radius that is smaller than 1 unit, but it's not too far off, right? 0.8, so just a little bit smaller than 1 unit. For number 71, we are subtracting 1/4 from x. So the x coordinate for our center of the circle is 1/4. And we put C out front to name this ordered pair. We are naming it capital C, and that normally just means center. For the y, what are we subtracting from our y coordinate? Well, it says y plus 2. So our y coordinate is -2. So for this center, the positive x, negative y, we are in quadrant 4. Starting at the origin, move to the right 1/4 of a unit, then move down 2 units. For number 71, this equals 45. Well, that means that our radius squared equals 45. To find the radius, we take the square root of each side. So r is equal to the square root of 45. Of course, 45 is not a perfect square. However, what do we think about this? 36 is a perfect square. Square root of 36 is 6. 49 is a perfect square. Square root of 49 is 7. Because 45 falls in between 6 and 7, we can already get an idea in our heads. How big is the square root of 45? How can I view that in my noggin? Well, 45 is in between 36 and 49. Therefore, the square root of 45 is in between 6 and 7. 45 is closer to 49. Therefore, the square root of 45 is going to be a number closer to 7 than it is 6. Probably a number like 6.9 approximately, maybe something like that, 6.8, not sure exactly. We can't take the square root of this because it is an irrational number. However, we do want to simplify it a little bit, and we do so by determining, is there a perfect square factor that makes up 45? And if so, we can factor it out by taking the square root of the perfect square factor according to our product rule of radicals. 45 can be rewritten as the product of 9 times 5. According to our product rule for radical expressions involving square root signs or any other nth root radical expression, 9 times 5 is 45. Thus, we can write as the following. And now evaluating the square root of 9 as 3. R is equal to 3 square roots of 5. And we can, again, confirm this using Desmos. I'm going to back out of here, leave, and under Math Tools, Scientific Calculator. Just to confirm here, square root of 45 is in fact between 6 and 7. Oh, not 6.9 at all, 6.7. That's okay. Again, the idea that it was closer to 7 than it is 6. Let's go ahead and also check what happens when we factor out the square root of 9. Of course, we know this is in fact 3. And then we multiply this to the square root of 5. Just confirming all of that. Yes, see, it's the same number, of course, because the equality property allows us to do this according to our product rule for radicals. And then again, writing this as 3 multiply the square root of 5, which is what we have here, 3 square roots of 5. It represents the same thing as the square root of 45. So we have a radius that's approximately 6.7 units. What is the exact value of that? Because if I wrote 6.7, I would be lying. This radius is actually larger than 6.7. That's what's wrong about rounding, is when you round, you are not telling the whole truth. So for radical expressions, we want to write the exact value, and that would be 3 square roots of 5. For our center and our radius for number 71. And in a moment, we will look at graphing. To graph the circle, graph the ordered pair, starting at the origin, move over 1/4 of a unit and move down 2 units, and plot your circle. From there, extend up, over, out, to the right, all four directions, and you can draw, and of course extend out that approximate 6.7 units, and then you can draw your circle around. I'm pretty sure on your WebAssign, it will allow you when you're graphing a circle to choose the circle option, and it'll ask you what is the center of your circle, and you will place 1/4 for X coordinate, -2 for Y coordinate, and it'll ask what is your radius, and you will place in 3 square roots of 5, and thus graphing your circle, you will have the graph of the circle for your circle equation. And in this case here, our circle equation, square of x minus 1/4 plus square of y plus 2 equal to 45, where we know the center is 1/4 comma -2, and the radius is 3 square roots of 5, approximately 6.7 units. So the general form of an equation of a circle is actually written out. The parentheses that are in the standard form, x minus h quantity squared plus the y minus k quantity squared, the squared binomials will be multiplied out into individual terms. For the following general form, x squared plus y squared plus cd plus dy plus e. Now, I believe there is a little bit of a typo in there. That should be plus c times x plus d times y plus e. I'm not sure what they did there with that one, but we'll see nonetheless how we can express an equation in general form. Looking at the first example, it says write an equation in general form for the following properties. Our center of the circle is at the ordered pair 6, 8 with a radius of 4. Let's go ahead and graph this circle first and foremost. With the center of 6, 8 and a radius of 4. Let's graph the circle, and then we will look at the equation of the graph. So with a center of 6, 8, that's going to be off in quadrant 1. So there we have the center of our circle. Well, we know the radius is the fixed distance between the center of our circle and then every ordered pair that makes up our circle. So what do we need to do here? Extending 4 units in every direction from the center, for example, for the 4 units below, that means we're going down to 4. So you see that distance right there is going to be 4. Now, taking that distance and like a clock, spinning it all the way around the center of a circle, keeping that fixed distance of 4 units, we will have every ordered pair that makes up the graph of this equation. To get an accurate depiction, what I like to do is I create a cross so that I then try to connect all 4 points on the outside using a smooth curve that represents a circle. Now the drawing might be off a bit, but we're doing the best we can. 4 units from 6 would be 2 and 10. 4 units from 8 would be 4 and 12. So extending this 4 units, in every direction. So of course, and it would be hard to do so, we would have to go in and use our distance formula over and over to find these exact points everywhere else. To get that exact point everywhere else, you would have to create many different triangles, and you would have to use a lot of properties from trigonometry involving sine, cosine, and tangent, and that is very applicable and doable, but for the time being, we do not work with those in the textbook, so we will leave that to pre-calculus and higher order classes, applied calculus, etc. A lot of fun though. Working with triangles, it's the same triangles over and over, so the numbers can be seen repeatedly. So for these 4 points here, again, not the best circle, but we have an idea. All of these ordered pairs on the outside, not the radius, not the center. With that highlight all the way around the outside, there's an infinite amount of ordered pairs that lie on this circle. Those ordered pairs together make up the circle for our graph. Now, what is the equation here? Using the center, using the radius. First part here says x minus the x coordinate of our center, so x minus 6, and that's being squared, plus y minus k squared, so y minus 8. This will equal the radius squared. Our radius squared is 4 squared, which is 16. This is the standard form for our circle equation. To get it in the general form, we want to write out what is x minus 6 squared? What is y minus 8 squared? And please do not write this as x squared minus 36. You would be wrong. X minus 6 squared is the square of a binomial, x minus 6 times x minus 6, and this will give us, using the FOIL method, x squared minus 12x plus 36, where our inner product and outer product are the same and they combine to give us negative 12x. Now we will add this to the square of y minus 8 using the same methods here. Y minus 8 multiply y minus 8. So after squaring each of these binomials, x squared minus 12x plus 36 plus y squared minus 16y plus 64 equals 16. Almost done here. Last thing we can do, and I want to make sure that we get this right exactly now, it tells us to keep everything on the left-hand side. Move everything to the left-hand side. So the x squared and the y squared are going to be moved out front. The x squared and y squared go out front, followed by the coefficient terms, or the variable terms, excuse me, negative 12x, negative 16y. What's left here, the 36 and the 64, which when you add them together gets 100. So there's a 100 left over on the left-hand side, and there's a 16 on the right-hand side. Now, these are real numbers, they're constants, we need to combine them. We want this equal to 0, according to our rule for the general equation for a circle. So subtracting 16 on each side to get 0 on the right, 100 minus 16, 84. So we have the general form for our circle equation, and also, of course, we had the standard form. And from this bit of information here, taking the general form and being able to view it in the standard form, we now get the visual of our center. Subtracting 6, therefore positive 6. Subtracting 8, therefore positive 8. And for the radius, the square root of 16, which is 4. In many cases, you'll be given the general equation and using what is called completing the square. What do we mean by completing the square? This is the square of a binomial. How do we get that? From this information here, we have to determine with x squared minus 12x, what is the constant that goes with that? Well, we know that is plus 36. So we extract the plus 36 from the 84, we extract the plus 64 from the 84, and we move over the constant that is remaining. That gives us the fit for the standard form, allowing us to determine our center and our radius. But at either rate, general form, standard form, center, radius, and of course to graph the center, which is just a point, using the radius of 4, extend out, and connect your circle on the outside. The center circle of the Kansas Jayhawks basketball court is a circle with a 12-foot diameter. If the center of the circle is located at the origin, find an equation in standard form that models the circle. What it's saying here, for a basketball court, the center of the circle there, imagine an x-axis that runs through the y-axis. The center of the circle, imagine as an origin, The origin is the ordered pair with coordinates 0, 0. It says here that the circle has a 12-foot diameter. A diameter is the measure from one end of the circle to the next. The radius is only half the diameter, so the radius in this case is 6 feet. So go to the full view. The diameter is this distance. The radius is going to be half that, therefore 6 feet. So to find an equation that represents the circle that is the center of the Kansas Jayhawks basketball court, using the center of the circle with the origin and using the diameter of 6 feet corresponding to a radius of 6 feet, x minus h squared, x minus the x coordinate is x minus 0 squared. Y minus k squared is y minus the y coordinate, and this equals r squared, 6 squared. Again, keep in mind, x minus 0 squared, if we're not subtracting anything from 0, we don't have to write this. We can just keep this as x squared. Same here. And now squaring the 6. So now we have this model, this equation that represents the center or the circle at the half court for the Kansas Jayhawks. For problem 125, looking at the coverage of CB radios in an 18-wheeler truck, the CB radio of a trucker covers the circular area shown in the illustration. Find an equation of that circle in general form. So we see there the position of the trucker has the coordinates 7, 4 with respect to the mapping of the local area. The local area there with a map, and again, when you look at maps, they're two-dimensional. So this is exactly how we have to use geographic location, our GPS, with two coordinates. We know that it's longitude and latitude. So thinking about 7 and 4, where 7 can be the latitude and 4 can be the longitude. They see that on the x-axis, an ordered pair is given that lies on the circle. That ordered pair 10, 0 lies on the circle or the graph of the circle, and we want to find an equation of that circle. If we can find, because we know what the center is, to find the equation of our circle, we need the center of our circle and we need the radius of our circle. Well, now that we have an ordered pair given to us that lies on the circle, and we have our fixed center, the radius can be found by finding the distance between those 2 points. Looking at our distance formula from section 1 of chapter 2, the distance formula derived from our Pythagorean theorem is the square root of the difference of our x coordinate squared added to the difference of our y coordinate squared. Here for number 125, the square root of our x coordinates, 7 minus 10 squared, added to the difference of y coordinates, 4 minus 0 squared. 7 minus 10 is negative 3. Squaring negative 3 is positive 9. 4 minus 0 is 4. 4 squared is 16. So our radius is the square root of 9 plus 16. Well, 9 plus 16 is 25. 25 is a perfect square, therefore the square root of 25 is 5. So we have found our radius. Our radius equals 5. We found that radius simply by finding the distance between our center, which is a fixed point, and one point on the outside of our circle. Because keep in mind, now that you know that distance is 5, whether that's 5 feet or 5 miles, 500 miles, we don't know what the measure is. If you take that fixed distance of r equals 5, and with that fixed point, just spin it, rotate it rather, all the way around that fixed point, and you will locate every single point that lies on the graph of this line. Basically, it's your outer boundary for the CB radio. We know that using the radius of 5 and using our fixed center of 7, 4, starting with the standard form equation for a circle, x subtract the x coordinate of our center, x subtract 7, that is being squared, plus y minus the y coordinate of our center, y minus 4, squared. This equals our radius squared, 5 squared, which is 25. So the standard form equation for our circle is as follows. It wants us to put it in general form, which just means get rid of these pesky parentheses. It's nice to have the standard form because what do we see here? In the standard form, we see that our center is 7, 4, and taking the square root of 25, we see that our radius is 5. So it's beautiful to have this. But now squaring x minus 7, which is simply x minus 7 multiply x minus 7, we get x squared minus 14x plus 49. To square y minus 4, which is y minus 4 multiply y minus 4, y squared minus 8y plus 16. This equals 25. But we don't want it to equal 25, we want it to equal 0. So to get rid of 25, we need to subtract both sides. So in other words, on this left-hand side, subtract 25. And that will equal for us 0. So the general form says take the x squared, the y squared, move it out front. Minus 14x minus 8y. Now 49 plus 16 is 65, minus 25 is 40. So we have our general form equation, which is the sum and difference of terms. This is normally how we would write it. But from here, at any time, by completing the square, we can rewrite it in standard form. X squared minus 14x. Well, what constant do we need to add to this to make this a perfect square trinomial? That's the plus 49. Here, the plus 16. So the 49 and 16 would be 65. What's left over? The minus 25 that we move over to the right to make positive 25. In the standard form addition, we can now identify the center to be 7, 4. And by taking the square root of 25, our radius is 5. So all of this is checking out for us. And again, the general form is set equal to 0, and there are no parentheses. Standard form gives us the center and the radius, and I digress.